another day, another calculus problem. Let's get it out of the way. I want to find the equation of a tangent line for this function, y equals x times ln x, when x equals 1. Here's how I'm going to get it. I'm going to get it by finding the slope of this line, and then I'm going to find a point that the line goes through. Remember that if you know the slope and you know a point, you're all set. Now, think about it. How do you find the slope of a tangent line? Did you say derivative? I hope you did, because that is how you do it. When you learned about the derivative, that was how it was first defined, and that's still what it means. So we're going to be finding the derivative of this. dy dx equals, look at this, x multiplied by ln x. This right here is a product rule problem. So remember that product rule goes like this. F times g, if you take the derivative of that product, it is f prime g plus g prime f. So they each get a turn. You take the derivative of the first, you multiply it by the normal version of the second, and then you add the derivative of the second times the normal version of the first. So dy dx will be the derivative of the x part, that's 1, times the normal version of the second part, that's ln x, plus, and now derivative of the second part is 1 over x, then multiplied by the normal version of the first part, that's x. We have to algebraically simplify this a bit. 1 times ln x is ln x, and 1 over x times x is 1. So the derivative of this will be ln x plus 1. Okay, when x equals 1, we're going to plug that into the derivative to get the slope of the tangent line. So when x equals 1, dy dx will be ln 1 plus 1. Now don't reach for a calculator, because this is one of those special logarithm values you should know. The logarithm any base, including e, log of 1 is equal to 0, because e to the 0 is how you get 1. So this is 0 plus 1, which is 1. So what this tells us is that the slope of the tangent line is 1. Okay, this is half the battle, and it's the hard part. The rest is not calculus, it's just algebra. Because now that we have the slope, that's the part where we use the derivative. Now we just need the actual point that it goes through. When x equals 1, y equals 1 times ln of 1. And once again, ln of 1 is going to be 0, right? So this will be 1 times 0, or 0. And it always feels weird for me to circle a 0 because it just looks like a donut. But the point here is going to be 1 because that was the x, and 0 because that's the y. Okay, so now we have a slope and we have a point. I don't know if you are comfortable with working with point slope form. If you prefer to be in slope intercept form, then, well, deal with it, because we're going to put this in point slope form at least at first, and then I will convert it to slope intercept form right after that. So I'm going to say y minus y1 equals m times x minus x1. This is point slope form. I put in the slope where the m is, and I put in the x1 and the y1 based on the point 1, 0. So y minus 0, which I kind of don't need to write, so I'll just get rid of those. Y equals m, which is 1, and I don't really need to write that either, but just for the look of the thing. Then x minus 1. Okay, so expanding through the parentheses, I'm going to get y equals x minus 1. And maybe a picture for this is a little bit too ambitious. But what it essentially means is that, let's see, the point is 1, comma 0. So this function is going to look something like this, and the tangent line is the line, the straight line that is tangent to it at that point. And the idea is that this -1 is the y-intercept of the tangent line, and its slope is 1. So it goes from -1 to, from 0, -1 to 1, 0. The important thing from a calculus perspective is that it's tangent to the graph. So this answers the question.